errors, they're successful, we need to know about that. Is it business doing well, or is it some hacker trying to bring down our service so that they can get money out of us? So all these is part of observability, and these tools, from a login perspective, Elasticsearch, Kibana, FileBeat, Logstash, they all play a role, and we've seen how they individually play their roles and how we can bring them together to make sense. Okay. And of course, the reason why we have this running in the cloud is very obvious. You can have them running on your servers if you had your physical data center, but you know what it is when it comes to scaling, when it comes to being agile, and even cost perspective as well for business. So today, let me share my screen so that we can quickly go through the agenda. Let's see. All right. So I have this, and then behind is my AWS. Okay. I hope you can see the screen. So what I would do is, let me increase the font of this a bit more. Say 16. Okay. And then we're just going to go through the agenda quickly. Chinwe is going to share this file with you so you can just have a read through as well. So the objective for today's class is to talk on monitoring, Prometheus Alert Manager, and Grafana precisely. And it's actually to provide with you guys a comprehensive understanding of setting up and managing a robust monitoring system for application and the infrastructure. So let's talk about the importance of monitoring. Okay. So early detection of issues. So we want to be aware of what's going on in our systems. That's why we want to monitor them. We want to capture some data from our metrics and use all these tools, put them together, and detect issues before they become problems. Okay. So Prometheus is that component that scripts data for us. Alert Manager is that component that helps us to alert our configured systems, whether it's Slack, email, PagerDuty, whatever system, wherever you want to receive the alerts, you can configure that and get notified when it's time to respond to certain rules. Then Grafana, similar to Kibana, is that tool that allows us to visualize the metrics. So in the world of logging, Elasticsearch stores the data and Kibana visualizes the data. So you can go into Kibana, you can run commands to show you the logs and how the data is flowing through, and you can see things from a visual angle. Grafana is that same thing, but in the world of metrics collection. So Prometheus stores the data, pretty much. Okay, so basically, Grafana uses Prometheus as the data source to pick the data, and then you can use Grafana to visualize it. So we're going to install all of those tools and see how they work. So optimizing performance, so monitoring metrics such as response times, for example, how quickly our systems respond to requests, and resource utilization helps in identifying bottlenecks. So if you see in the Grafana dashboard that it's taking a bit of time for our systems to respond, that means that our users, when they try to download a file or they're trying to upload or something is happening, our users are experiencing delay. And you know how it is when, imagine going to the ATM and you slot your card in and you're waiting 5 minutes for the display to even tell you what your balance is. You're frustrated because you probably have like 100 people lining up behind you waiting for you to get out of the way, and they're mounting pressure on you, and you're pressured, you're just not happy that's happening. So as a business, you want to make sure you avoid that frustration, which is not only going to affect one person, it's going to affect a lot of people. And ultimately, if that keeps happening, people will just go to a different business. So you can see how this connects to the business. Yes, we're monitoring our systems. We also have to make sure that we're doing things that fit into what the business goals are, which is, for example, customer experience, right? So when we have observability in place, monitoring things like this, it will help us to identify the bottlenecks, because now we know there's a problem. We can go into a drill down. If it's a microservice architecture whereby there are different components within our software, let's say we have a service doing the login and authentication. We have another one that is maybe loading the dashboard, okay, giving us data about the service. Yeah. Now, someone is trying to log in, but it's taking some time. So the response rate is very slow. But when we start digging into it, it could be a case where between the authentication service and the dashboard service, there's actual delay in there. Maybe because even the dashboard service needs to talk to a database that is taking longer time to retrieve. You can see how they have affected each other. So understanding things like that will help us to identify where the bottleneck is, because at the end of the day, the bottleneck could actually be the disk storing data that the database is using. Imagine if we had our MySQL database running on some server and it's using a hard drive that is not SSD, so the response time is going to take the software to retrieve that data is going to take long. And of course, the other service that needs to display that data has to wait for the data to reach the dashboard service, so you can see how that journey is. And eventually, if we are not able to drill into the data and see, it will be hard for us to then identify where to optimize for performance. Okay. So enhancing reliability and availability. So proactive alerts and thresholds prevent unexpected outages, maintaining systems availability and user satisfaction. So for example, if we set certain threshold that, okay, please let me know when the CPU usage has reached 95%. So that's the threshold that we've set. And we've set it to alert us at that point for critical alert. But we can also set another alert, which is the warning alert that says, okay, alert me when the CPU spike has reached 80%. So between 80% and let's say 95%, which is the critical, or 90%, it doesn't matter, you can determine that. Okay, between that gap, you receive the warning alert at first. You have the opportunity to go into the system and try to analyze why the CPU has spiked up and what's happening, okay, before it gets to the critical alert. Now, at this point, your customers are not experiencing anything. It's just a system that is hitting a high CPU usage. But if we don't monitor that to go in and analyze what's going on and fix the problem, it will get to 100%, and then the system will crash, and then your users won't be able to access the service. So to ensure reliability on our system, we can proactively set alerts and thresholds so that unexpected outages can be prevented early. Then data-driven decision making, obviously, because we're capturing a lot of data, we can look at it and make good decision based on data. For example, we may have historical data and we know that a certain time of the year we hit certain limits. So because we have that information, we can better prepare ourselves. In a system where maybe there is no auto scaling, we're manually handling the scaling, that's an opportunity for you to know when it's time to scale the systems. Or maybe we're even using auto scaling. But even with auto scaling, you can set threshold, minimum and maximum. So with data, we can tell that, well, even this maximum that we are setting is not sufficient. So we're not just randomly setting some figures. We're setting them based on data. And because we have historical data about how our systems work, we can then make that decision and say, okay, we want to configure auto scaling, no problem. Minimum of 2, maximum of 10. The 10 that we have set it to is not just randomly selected number. It's actually a number that we've set because we know that our systems don't go beyond 10 usage. It's probably between 6 and 8 or something like that. Okay. Then continuous improvement, regular analysis of monitoring data drives iterative updates and adjustments for enhanced system stability. You understand that. And user-centric experience monitoring ensures quick issue resolution, providing users with a reliable and responsive experience. So I believe this part makes a lot more sense to you why you would want to put in systems like this. And these sort of projects could even take your team a few months to put everything together. And of course, that's cost to the business because you pay salaries, you pay for systems that you're using, things like that. So you wonder, why would a company invest so much in putting monitoring together? Now you know why. It's a very critical part of systems. Yeah. Okay, so we're going to be talking about 3 different tools: the Prometheus, Alert Manager, and Grafana. And Prometheus is an open source. And by the way, they're actually all open source, so you don't get to pay license for these tools. So it's not like Elasticstack where you still have to pay license to use. But with these ones, they're open source, it's community driven. Everyone, you can contribute to it if you know how to program in Golang, which is the language that it was developed with. So it's an open source monitoring and alerting system. So it collects time series data from various sources such as applications, infrastructure components, and Prometheus stores and analyzes metrics, providing insight into system behavior and performance. And we're going to see all that today. It supports a flexible query language for data analysis, and its role in monitoring stack is the core component of collecting and storing metrics, forming the foundation of observability. Because how can you observe a system when you're not capturing data in the first place? So this is that allows us to capture the data in the first place. And the way it does it is not the traditional database that you may think of, like Elasticsearch, for example. It's putting the data in some disk. It's stored somewhere using JSON and whatnot. The way Prometheus does it, it basically scrapes an HTTP endpoint. Okay, and there are other configurations you can actually have. There's a database called, I can't remember, I'll search for it now. But you can implement Grafana and Prometheus actually use another time series database, but that's not common. But with this 3 stack, you're good to go. Now, Alert Manager, this is the component that works alongside Prometheus. So it manages and dispatches alerts generated based on predefined conditions. Alert Manager routes alerts to appropriate channels like email, chat platforms like Slack, other alerting systems. Wherever you want the alert to go to, you can configure Alert Manager to send it to it. It supports deduplication and grouping of alerts for efficient notification management, so that if you have multiple alerts going on, it becomes a noise if you don't manage it properly. So with Alert Manager, you're able to organize your alerts into groups, and it avoids the duplication of sending the alerts, so you don't get noisy situations. Then Grafana, which, like I said before, it's also open source, but it's the data visualization tool. Now, with Grafana, you don't have to necessarily use it with monitoring alone of systems. You can actually use it even with any other thing. You can connect your spreadsheet, Excel to it. You can connect your MySQL database to it. You can connect any other. It's just a visualization tool, but it works very well with Prometheus because you can connect to it and selecting Prometheus as a data source. So you can have multiple data sources that you can connect to your visualization tool, and you can then just go in and start creating dashboards. And we'll go into that as well. Okay, so let's start our implementation. So we've talked about Prometheus, what it is, and some of the important key concepts we need to learn about Prometheus before we get started is the fact that, number one, metrics. So numeric data points representing system or application characteristics like CPU latency, CPU usage, request latency. Like I said before, you want to monitor your response rate. You want to see how many times you're getting 200 status codes, for example, as compared to 500 or 400 or 4xs or any of those, things like that you can put together and monitor them because you're capturing that data. CPU usage, again, memory usage, all those kind of things. These are metrics, and time series, meaning as the clock ticks, it's capturing all that data. Then scraping is a concept in Prometheus. So it's the process of fetching metrics from a designated endpoint. Okay, so we're going to see the endpoint as well. And basically, once we have that endpoint, Prometheus just goes there using HTTP protocol, and it just keeps scraping the data. Okay. Then we have this PromQL, which is the Prometheus query language, which you can use for querying and analyzing the collected metrics. And it's the same thing that Grafana uses. So in Grafana, you can put those query PromQL there, which it will constantly be running. And based on the return data, it will visualize it. Then there is alerting rules. So you can define certain rules that will be evaluated for it to trigger. So you want to set it to trigger when the system is up or down, right? So you set the rules and then it just responds based on that. Data retention, metrics are stored for a configurable retention period. So if you can have like a high availability system whereby, or maybe you have multiple Prometheus instances running, all putting that data in a place, and you can set at what point you want data to be flushed out if you can't keep data for too long. Service discovery. So this is the automatic discovery of system. And you're going to enjoy this more when we get to Kubernetes, where we start talking about service discovery and how Prometheus can quickly discover services within your infrastructure without actually going into Prometheus to configure that service. Okay, now this is an advanced concept. So federation, it's when you aggregate metrics from multiple Prometheus instances for larger setups. Prometheus, standard configuration of Prometheus fit into most use cases. So it's very rare before you find a federated configuration to be required. But if the need arises, it's capable of having multiple Prometheus instances, to handle a larger situation. All right. So what we're going to do next is I'm going to bring up first of all, let's go into AWS. Any questions so far before we go into implementation? By the way, this is servers from last week or 2 weeks ago. So we have monitoring the Apache and everything. So what I'll probably do is spin up 2 more instances today. So one is going to be for Prometheus, Grafana, a lab manager. And then the other one be just install maybe Apache on it. Okay. All right. Because this other Apache was the one we used for elk. So I'm just going to probably just terminate that. Okay, I'll just stop it for now.
Just a quick question, Dawi.
Yes.
Yeah, my name is Yemi. So the alert manager, you mentioned you're installing it on a separate server. Can we also have it on the same Prometheus server, the Prometheus and Grafana server, or is it best practice to have it on a separate server?
So best practice will be have each of these services on their own separate servers. Again, it depends on a number of factors. If you have an instance that has just maybe 4 gig of RAM, you'd rather separate them because And different teams are using that Grafana, right? Just because you have Grafana and Prometheus on the same server, you literally made the system unusable for everyone. So always think about single point of failure when you are making such decisions. So I would recommend put them on separate servers, okay, and connect them all together.
All right, thank you.
All right. I'm looking for that option to create launch launch more like this. That's what I'm looking for. Select, or how many did I select? Image, no, not image. Oh, goodness. Launch instances. That's the what I want. I just want it to launch from this template. Launch itself from template. No, not from. Can somebody help me? Image.
Image and launch.
Oh, okay, this is it. Launch more like this. That's what I'm looking for. But it's greater. Oh, sorry. It's because it's terminated. That's why. Okay, I can use this one. I was wondering what's going on. There we go. Okay, so I need 2 servers. And I'm going to name it Prometheus Alert Manager Grafana. Okay, so these are the 3 things I'm going to put on here. On purpose, I won't put Apache here. We'll put it on a different server so you get an idea of how to get them to talk to each other. All right, so size 8 gig of RAM, that should be fine. And then key pair monitoring. Okay, that's fine. We can leave all this. Enable assign public IP. Okay, we can use that existing security group that we have. And by the way, from next week, I don't know if we have a session next week or the week after, but we'll look at the calendar. That's where we'll start putting best practice into things. And by the way, one thing I would also recommend for you guys ahead is, if you can, look back into the architecture for environment separation. All we're doing right now is putting monitoring into one environment. So all the logging and monitoring and everything is going to be in our monitoring environment, okay, or tooling environment, because that's where we're going to be putting tools. Now, that environment could be a separate AWS account. It could be a VPC. It could be a subnet, depending on your environment separation strategy. But I would recommend for you, when you have time, or it could be at the end of the whole program, you want to try and, practice things all over again and tear things down and start building yourself. Build your tooling infrastructure, put it somewhere. The business infrastructure environment, which we're going to start next, put in there, considering auto-scaling group, load balancers. You can even do the same thing for your tooling environment with load balancer, with auto-scaling, with, all that. The same concept remains the same. It can be challenging. It can take a bit of time. The challenge here is not even in terms of technical expertise anymore, because now you have the skills, you know what you're doing, but it does take time. Sometimes you create some services and you have to troubleshoot to get the connectivity to work, especially because you're working with different environments, and maybe you need to pair VPCs together and, things like that. But it'll be a great experience for you to actually sit down, dedicate some time to go through all that. And you can be doing all that while you're interviewing, so that you're not wasting time learning and waiting, so you can be going for interviews every now and then. You're practicing, you're doing all those things. So it's very important. So don't just take the things that we learn in class and just end it there. Now you understand the concept, okay? So take the concept and try to build on top of them. The things that we're talking about, try to expand them. Don't just think this is the end of it, okay? So that's why we're trying to as much as possible, give you the information from a real world perspective. All right, so I think we're good. We can launch an instance now, right? We're launching 2. So both of them will, so what I would do is let me just filter by this, so we only have those 2. And why this thing, let me refresh this. Okay, there we go. It's only showing the one that's terminated. Let's clear filters. Okay, this is the one we just created. Okay, there we go. So I'm going to just name this Apache. Okay, the reason for that is because we need to configure and see a scenario where a web service is running and it's capturing some data around it. All right, so let's get the IP address and let's bring up our terminal. So I have this terminal right here. We are probably going to need just 2. So let me delete 1, and I will name this. I'll name this Prometheus Grafana Alert Manager. Yeah, and I can give it an interesting color. Blue. Yellow. Okay. Click to set. There we go. And this is going to be Apache. Okay. With that blue. All right. Okay, so in my folder, I have this notes. You're going to have access to this notes. So it will be part of what Jim will be sent out afterwards. So it's a follow-up of different things that we're working on. But we have a note for Lab Manager. We have for Apache Exporter, because we're going to be working with exporters. If we have time, we could do with Nginx Exporter, but we'll see. And we have for Grafana as well as Prometheus. So let's start with Prometheus. Yeah. Okay. So let me expand it like this. Let me know if it's too small, if I need to expand it. Okay, I've tried to expand it. And I have this monitoring.pem key. So what I would do is to first get the IP address so we can get onto that server. So SSH and that. We're in the server. And the first thing, let's just quickly go through some of the things here. Let's see. Is this too small? Can you see it? I hope you can. So we're going to create a group on the system. We'll name it Prometheus. We'll add a user. We'll create a user and add the user to the, both of them will be called Prometheus. And we'll make sure that no one can actually log into the system with the user. It's a service account. So this is what is called a service account. So it's an account that is being used by a service. So it's not one that a user, a human, needs to use to log in. Okay, it's an application that's going to be using that user to run. and that user is called Prometheus. And then we'll create a folder in this valid directory where we'll put Prometheus, and then we will create some folder. I mean, this is not quite necessary. It depends on when we start configuring rules. I mean, we can just ignore that, to be honest. But the most important part is updating the system, installing some of the tools like wget, Perl, Vim, if you don't already have it. And then we will create a temporary directory where we can extract the Prometheus binary. And then it's going to come in the form of a tar.gz, and we're going to extract that into a Prometheus folder. So we can run this. So we'll put the binary into a user local bin so that we can just run Prometheus version straight away. And that way we know that Prometheus is pretty much installed. So installing Prometheus here is as simple as downloading the binary and putting it in the bin folder. Now, let's first of all have a look at what's in the bin folder. So if we go into the USR local bin folder, yeah, there's nothing there. But actually, let's see if there's another bin folder on the system. Right, okay. There is indeed, but let's see. Actually, so we have this command called ls or pwd. Okay, so if I do which pwd, it tells us that it's inside the USR bin. So any program command that you just want to run on the terminal, if you put it in the bin folder, you can just run it and it will work. So let's see what's inside this USR bin. So we have all these in USR bin, and one thing that will be interesting to you is we checked USR bin the other time, and did we check this one? Okay, this one is empty. So if we check USR bin, and I think was it? Okay, it was USR bin, right? Is there any other? Okay, there is. Right. Okay. So there is the /bin and there is the /USR bin. And one thing you notice is they're both pointing to the same place. Okay. So if I run USR bin, notice you have vi, you have all this command, telnet and all that. So it's basically returning the same thing, vi, telnet, and that's because if you do a list on USR, okay, that is bin. Let's see the other one. Okay, on the root, you can see that bin is pointing to USR bin. So it doesn't matter where. So whether you check in bin or USR bin, they're actually both pointing to the same place. Okay, so in some systems, and that's why in this right here, this is pointing to USR local bin. And when I did it, actually works, but I'll imagine that's because there's something called path variable. So you can see this path. These are the different paths that it look into to check where there are binaries. So you can see here there's USR local bin, USR local bin, and that's the one that we were going to install Prometheus, and that's why we can install Prometheus there, and we can just run Prometheus and it just works. Yeah. And there is USR bin. So any of these bin folders, if you put a binary in there, you basically just run the command like we would normally do like this in the terminal. It basically goes into any of this path and just responds and does what the command is intended to do. All right. So that's just a quick Linux overview of that. So let's begin our installations. Okay, and let's copy all these. So this is going to take all the So it's going to download the binary. And by the way, if you go to this, so you have to be curious, okay, when you're doing all these things, be curious, take the link, go, okay, what's going on here? This is what's going on here. And if we go back into our, where is it? Our command, try to understand what this whole command is doing. So it's going into this web page that has a JSON data there, and it's grepping download URL. So if I go in there, and if I'm so curious, I want to know, okay, what's going on with that? I can come here and search. Oh, there is a key here called download URL. How many? We have about 36. Okay, what does that mean? That means there are different types that we can download. So for example, this is for Darwin, which means if you wanted this to be downloaded for a Mac-based system, you have to download this version. And this is for Dragonfly, another type of system. This is for FreeBSD. So you can see these are the different types that you can have. And this is Linux AMD, and that's the one that we're interested in. Okay, so if you then see, okay, so once we grep these, well, we're also grepping for Linux AMD 64, which is the one that we're interested in. And we're running this cut command, which basically tries to extract the part of this. Let me show you. It basically extracts the part that we're looking for, because remember, it goes and find browser download URL, which we have about 36 of them, but then it filters by the one that has Linux AMD 64. Good. That means we've grabbed what we want. But we don't need the whole of this to download. Okay, all we need is this. This is just what we need, yeah? So we need to use the cut command to then determine, first of all, what's our delimiter. Okay, so it's using, so the -d here is the delimiter. So it's using this, what's that, double quotes as the delimiter. And then it's looking for the fourth, would I say, column or the element in what it's extracted. And by the way, this is not rocket science. This is something that you can actually do on your own until you get it. So getting this didn't come by just knowing what number to use. As you can see here, I'd actually tried different. The first time I tried it, I put 2, but the return data, let me show you. The return data from here was just browser URL. Okay, so it extracted browser URL. So, okay, fine. Let's cut out 3. What does that give me? Well, it gives me colon. So that is between, let's go back to it. Okay, so between this and that, so this is 3, right? So that's why it's giving me back this colon. All right, so if I put 4, okay, then it gives me the whole thing, and this is what I'm looking for. So I'm just trying to extract this. And these are skills that you start getting to understand gradually when it comes to automation. When you're trying to automate things, you're using strategies like this to extract things you want, and you can just pick it. Imagine if you want to automate the installation of Prometheus, you know exactly what you're looking for. You can then just put that in a shell script. And it's another opportunity for you to improve your shell script, because you can then think, okay, how can I even improve this? What if whoever wants to run this script, they don't know whether it's going to be running on Mac or Linux or Windows or whatnot? Then you can parameterize something like this and put a variable in there and say, okay, at the time of running this script, pass in the system you want. So whether it's AMD or Darwin or whatever, so there's so many things you can think of to expand your knowledge about things that you're learning. All right. So back to the actual meat of what we're trying to do. So we have, oops, I hope I haven't forgotten. So the last command we ran was cd Prometheus star, which means that, let me just clear the screen and go back one level before I lose you guys. Okay, so we downloaded this and we extracted these into this. Okay, that's what's going on. So if you list in here, you can see what's in there. And inside it, we have this binary. So this is a binary, Prometheus. This prompt tool is another binary that you can use to work with Prometheus. Okay. So the other command is basically just doing a CD into that folder, CD Prometheus star. And that's because, the whole of this, we don't know what it is. So it's just the version and all that. So we just put an asterisk to go into it. And now we're inside the folder. Okay. Make sense? Any questions? So as we're trying to learn about observability and everything, we're also learning Linux and making sure we fully understand what we are doing. So now that we have that, what do we want to do? We want to move our Prometheus and prompt tool command binaries into the USR local bin folder so that we can basically just run our Prometheus and prompt tool commands. If, for example, I run Prometheus version right now, you see command Prometheus not found but can be installed. So it thinks that this is not installed. Okay. And when we install things on Linux, especially binaries, they have to be in in any of the path. Okay, in any of this path. Otherwise, what we can do is we can, rather than run Prometheus version, we can point to the actual Prometheus location. In this case, will be let's say, okay, let's do it this way. So pwd. So if I copy all of that and do that, / and because we know Prometheus binary is in this folder, and then I say version, that's going to work because the binary, I have actually fully qualified the location. But obviously, you can't know where things are located on the Linux system unless it exists in the path folder. And that's why we have to move it into the path folder. Okay, makes sense? So we're moving both of them. So both Prometheus and prompt tool, these two. So now that we have that moved, we can then run Prometheus version, and there we go. We have it. Or we can run from tool, even using tab now is able to pick it up because all I typed was prom and the tab on my keyboard. If I do double tap, it tells me there are two after prom. So which one? I put the next one, T, and then tab, and it tells me, okay, two. And then I can run version on that, and there we go, we have that, okay? So this is like, we've installed the binary, but it's not running as a service yet, And by the way, one interview question you have to be aware of, especially if you're interviewing for a role that expects you to have Linux skills, is to understand the difference between init systems and Systemctl. So we've been trying to recruit for DevOps engineers recently, and this is one question that I get to ask a lot, and it's surprising to know that a lot of people that have Kubernetes, Docker, CI/CD skills don't know the very elementary things around Linux that you should actually know. Very hard to find people who can understand the difference between a service on a Linux system and a process, okay, running on a Linux system. So when you have a software installed and you want it to continuously run, or you want to be able to manage it when it started or when it stopped, or you want to check the status, you want to restart it, you need a system that can allow you to do that. And systemd is the modern system that allows you to do that. Init D is like the older version, which both of them, there is a lot more to them than just managing services. Now the init, if you have worked on Linux for some time, you notice that you can either use service command or systemctl to manage services. Yeah. But these systems, they actually go beyond just monitoring the services. Okay. When it comes to booting up a Linux system, it goes through what is called a boot process. And this is something very, very crucial for you guys to understand. Okay, from an init system, there is init 0, init 1, 2, 3, all the way to 6. If you go on a Linux system and you type in init 0, what you're doing is you're shutting down the system. Okay, and that ties into managing the boot process and services and how things run on init on the Linux system. Okay, so this is something interesting for you guys to go back and read up and try to learn, watch videos, learn about init system, systemd, and the Linux boot process. Okay, if anyone is planning to write a Red Hat certification exam, for example, this, you can't escape it, it's going to come up. So Linux boot process. Yeah. So go check it out. All right. So that was just by the way. Okay, so now we need to get this Prometheus to run as a service. All right, before we even do that, okay, because this is where we get to configure the systemd. But before we do that, what we want to do is we want to check this Prometheus configuration file. So just like Kibana, Elasticsearch, and all that, they all have their YAML file that they use to configure the system. Prometheus also has its own. So second. Okay, it's not there. So, right. Okay, we have it right here. So this is it. It's still inside the folder that we extracted. Okay, so if we go and open that, you can see this is the configuration. And this is where you configure a lot manager configuration, rules. We'll talk about rules shortly. But first of all, we'll talk about scripting configurations. You know, remember Prometheus scripts endpoint. So you can configure the endpoint, but the default one is /metrics. So if you go to, let's say, localhost colon 1990, you know, Prometheus listens on 1990 /metrics, you'll see those metrics. We'll see them now. Okay, so okay, let's move this. Not as much. Wonder how oh, okay, guys. See. Okay, this was the command I commented. I skipped this part. But the thing is, I didn't want to create everything. So what I would do is I'll just create this one alone. Okay. Sudo. All right. And then we can move this configuration file into our newly created etc Prometheus folder. Okay. We have a few other folders. So we have the console libraries. Oops. Okay, we have this. So we're just going to move everything into this etc. An etc folder is where you keep configuration files. Yeah. So let's just move them over. Okay. And now we have Prometheus configured. Oops. Prometheus. Okay, so we have those things. The next thing is optionally you can move home, which is your home folder. So now we're in home. And then it's time to configure system D. So we want to configure Prometheus service. And basically, one of the most important thing here is how you start Prometheus. So you can run the Prometheus command, which is the binary we just installed. Okay. And then we pass in the configuration file. Okay, we pass in where we want it to store data. It's also using this console and console libraries as well. And we're telling it to listen on 000, which is on any endpoint on port 9090. And this is empty. I don't know what that is, to be honest, but with this configuration, we should be fine to have our service created. Okay. All right. So now we can the reason why I'm avoiding these rules and all that is because I don't want to confuse you guys, because when we start configuring rules, we don't need all these extras. So what I would do is I would just, don't worry, it will be cleaned up before you get this. Okay, so this is what we need. So we're setting this etc Prometheus folder to the owner and group Prometheus that we created earlier on, and we're setting the permission to 775. By now, you should understand Linux file permissions. If you don't, you shouldn't be in this class. All right, so we have that configured, and
sorry to interrupt.
okay.
Can you increase your screen? Your font is really small.
Okay, is that for the terminal or the Visual Studio Code?
The Visual Studio Code, but both if possible.
Okay, all right. The Visual Studio Code, to be honest, I don't know how I can increase these except I enlarge it like that. If anyone knows how to increase font, you can please.
Command and the plus work.
Oh, okay, that works. Oh, okay, yes. Thank you. I thought that would only work for the terminal. All right, cool. So I hope this is better now. Okay. So now that we have the permission set, we can then use Systemctl to reload the daemon, start Prometheus, and enable it so that if the system gets rebooted, the service can start upon startup. Okay, and we can check the status. Okay, it's not running. We have a bit of a problem. Okay, that's because we as part of, okay, so where it's keeping the data is valid Prometheus, and we didn't set the permission for that. So that's the reason that didn't. Okay, so let's start. Let's restart it. Is someone trying to ask a question? Okay, there we go. So we're good. So, all right. So now, all right. So now, now that we have Prometheus, let's go back to our notes. Prometheus is pretty much running, and we can just go to our browser and check it out. But we need to pick up the IP address. And remember, it listens on port 9090. And there we go. That's Prometheus. It's a very boring UI, okay, but a very powerful tool as well. So first thing, status. We'll talk about rules shortly, but the first thing is let's talk about target. So if I go to target, the only target we have right now is these localhost 1998 metrics endpoint. And who can tell me what this endpoint is? What does this mean? Localhost 1990. Anyone wants
this
to?
This is the endpoint of the server where Prometheus is installed.
Good. So this is Prometheus itself, monitoring itself. Okay, so it's not monitoring anything else. It's not scraping data from any endpoint other than itself at the moment. Okay, the state is up and it has some labels. Instance is 1990 and the job is Prometheus. So a job here basically represents the the configuration of an endpoint or a service that Prometheus is scraping its data or its endpoint. So that information, we can see it from the Prometheus configuration. So that's in etc Prometheus, and we have the Prometheus configuration file. And you can see job name Prometheus, okay? Static config is where you configure targets, and the target in this case is localhost. So you can see by default, installing Prometheus, this Prometheus YAML basically uses, has just one configuration, which is to monitor itself. So what we're going to do is to monitor another service, and that's where we will talk about exporters, okay? So as part of Prometheus, Alert Manager, Grafana is a concept called exporters. Now think of exporters like FileBit in the world of logging, where we have a bit, so not just bit, actually think of exporters as bits, because bits, it could be FileBit, it could be metric bit, it could be audit bit, it could be any bit for specific moving of data, right? So in this case, we have exporters. So there's Apache exporter, there is black box exporter, there's quite a number of exporters. There's a whole lot of exporters. There's node exporters. And each of these exporters, they export specific type of metrics. So if we configure Apache exporter, for example, it will only be exporting data related to the Apache web server. If we install and configure node exporter, it will help us to capture data about the node, metadata about the node, everything about the node, the CPU, everything running about it, and export it. So the CPU that Apache is using is not the same CPU data that node exporter will send, which is the CPU about the whole system. See? So when you start dealing with monitoring, you have to think about, the things, the kind of data you want and how you want to consolidate them and put them into Grafana. So what we will do is in my notes, I have a note here for Apache exporter. So we will install an exporter, same way we have installed Prometheus, similar process. We will then just go in, create a service for the Apache exporter and start the service, and then we will create another job points to the IP address of the Apache system. Oops. I hope you can hear me. Okay, I had someone trying to call me on Slack. What's it called? I'm sorry. Apologies. Okay. So we point it to the server where Apache is running, and we can just go into Prometheus and we see it there. Okay. All right. So what's going to happen is let's go into AWS, and then we get to minimize that. Let's get the IP address. So this is our Apache. So we will install Apache and then we'll install the Apache export. Okay. Oops. I didn't mean to do that. But now we have to separate. Can't join it together. But anyway, that's fine. Let me just bring this down and take this up. Okay, this is Prometheus in blue, and this is Apache. Okay. So what we will do is we will SSH into our Apache server. Okay, and first thing, let's just add Apache here and install Apache. So we're going to update and install Apache. And then we will do the same thing. Let's just run everything together. So download the Apache exporter binary and put it in the bin path. Okay, all right, there we go. And let's run. Okay, so we have Apache exporter, the version ready to go. Okay, so on this system, we are also going to create the Prometheus, because this is part of the Prometheus stuff, right? So we could just create the user and the group, and then we will configure the service. And then we can just reload and start the service. There we go. Good. And that's it, job done. So what we want to do is go into Prometheus and configure a new job. Okay, so we just go all the way down. And we'll add that. So what's the IP address? Let's get the IP address. And by the way, Apache exporter. So each of these exporters, they listen on their own port. Apache exporter listens on 9117. Okay. And we're giving it a name, Apache. I mean, just name it Apache rather than say Apache 2. And just give it a list Apache as well, if we want. And now it probably won't pick it up yet. Okay, so if we refresh, it won't pick it up. So what we'll have to do is we'll have to restart Prometheus. So if we restart it and refresh, let's see. Let's refresh again because we're restarting it. Okay, you can see, first of all, Prometheus endpoint is fine. Apache, it's still unknown at this point, but you can see it's picked it up from the configuration. Okay. And that's because, you know, it's still trying to figure out, it's going to do some ping. If you refresh it again, it should become green. And now you have a new endpoint that you're tracking. So if we go to the Apache exporter endpoint, the endpoint rather, okay, you can see this is its metrics. Okay. Similarly, if we go to Prometheus endpoint, okay, now because this has configuration for local hosts, it's just resolving into the private IP name or whatnot of that server. So we could just go into it and in AWS get the public IP and replace that. Okay. And you can see, so this is the HTTP endpoint that Prometheus just goes into. And you see all these numbers, okay, this is the data that it's working with. So if we keep refreshing it, you can see the numbers keep changing. Okay, I hope, let me zoom it a little bit. So if we keep refreshing, you can see the numbers keep changing. It's not static. As you can see here, we have Apache configuration that is being picked up. And every time you put in a new service, it all keeps getting posted to this endpoint, and Prometheus can keep coming here and capture data. All right. So this is still building up on all of these things. So there are many exporters. I mean, if you go to Google and just say Prometheus exporters, depending on what you're interested in. There are so many exporters with different databases. MySQL exporter, which is going to be exporting metrics about your MySQL database, PostgreSQL database, hardware. If you're an engineer, a network engineer that has worked with a lot of these hardware programs, you can see even Windows have their own exporters. So there's so many things you can do. Kafka exporter as well. If you're working with Kafka and you want to go into the Kafka topics and schema registry or the Kafka brokers or whatnot, it exports as much data about these, systems. HTTP, this is the one that we've just worked with, Apache, there's Nginx, there's many others, for different APIs as well. So the possibility is pretty much endless, honestly. There's a lot. But one thing, I don't know, let's see, black box is here. Okay, so black box exporter. All right, so this is going to be part of your homework today. So you should play with black box exporter and try to read the documentation, see what it does, and put it on your CV. Okay, so and remember what I said at the start of our training, that's all these different terminology. I hope you're keeping a notepad where you're just putting them there, because that's what we're going to use to generate your CV. It basically means you've gone through this, you know about these things, and if you are using our add-on service, we're going to need that to put your CV together. And that's very important because you want to go into a CV and they're asking you questions based on what's on your CV. Okay. The embarrassing thing is when they ask you questions that's on your CV and you're not able to respond, you're not able to at least talk about it. So that's very important. All right. So, but we'll get to that by the end. Black box exporter is very powerful. It's able to do a lot of things. All right. So the next thing we're going to do is to quickly have a look at how a lab manager works. Okay. And then we'll quickly go into Grafana so that we can wrap up for today. Okay, so we'll come back to that. So a lab manager. So again, standard stuff, we're just going to, install things. So what we'll do is we'll put a lab manager on the same server that Prometheus is running. Okay, and I believe this is it right here. So let's cd into temp, and we're going to download the lab manager binary. And we are going to, so you can see this is very easy, the same thing, we're just repeating the same thing over and over again. All right, and we're going to make a folder in C for a lab manager. Okay, and by the way, we've downloaded a lab manager, we've extracted it. So if I list in there, you can see we have our lab manager. So the same way Prometheus has prompt tool, which is just a binary you can use to work with Prometheus from the CLI. Similarly, a lab manager has a tool. You can use it to configure those YAML files without opening the YAML file, but I hardly ever use it, to be honest. So I want to be able to work with the YAML, those YAML files directly. Okay, so we want to move this into the, actually, we didn't actually need to do this. So let me remove that. Because moving this into Etsy, it's just going to basically rename this into a lab manager and we're good. So let me just remove that. Okay. And so we're just going to move it over and set some permissions. Probably just run in the interest of time. All these at once. Okay, seem to have worked. So what we did, we moved this into a lab manager, and then we set permissions, and then we created a new folder for data where a lab manager is going to keep some data. And when we're starting a lab manager, the same way we did for Prometheus, we're going to tell it the path that it's going to store data in a config file node. Okay. All right, so it's now in HCL manager, just like we have for this is just trying to keep things consistent, just the same way we have Prometheus configuration in Prometheus. All right, so I'm using Nano this time, so whichever one, doesn't matter, whichever one you're comfortable with. Okay, I'm just going to paste that and Control X, Y, enter. Okay. And now we're just going to reload and start. Alert manager. So status. So alert manager is running and we're good. So what we now want to do is go into Prometheus and create a new job. Okay, because in the targets, we're only having 2 targets, which is Prometheus and Apache. Okay. So see, you can even filter. And in the real world, you're going to see a lot of services here. So bear that in mind. All right, so what do we want to do? We want to go into Prometheus or YAML and then set that. So let's open etc Prometheus YAML. Make sure you open it with sudo. And then we're going to add a new service. So in this case, alert manager. So the first thing we're doing is just to be able to monitor alert manager itself. Okay, so we're not configuring alert yet. We're just, making sure that Prometheus can now begin to monitor that service to tell us when it's up or down. Okay. So let's restart Prometheus again and refresh. Start first, not so good. Because it's restarting, Prometheus is down, it's still trying to come up, and alert manager, it's been picked up. It's not yet up, show more to see what's going on. It's been never scraped, and by the way, it tells us the last time it's scraped for data. Let's keep refreshing to see. Okay, now alert manager is up, and we can also go in to see the kind of metrics it's been reported by alert manager. Okay, that's because it doesn't like this right here. Okay, so if I search, you can see there's alert manager all over the place. So this is the bunch of data that it's coming up with. Okay. All right, so let's go back. And the next thing we want to do is then see how alert manager works from an alerting perspective. So the first thing is rules. So for alert manager to understand when to alert, it needs to know the kind of rules to look out for. So the first one here, it says alert status or system status. We can even name it some like system status. So we want to be alerted when our system is up or down. So if you go to Prometheus, there's something called the expression menu right here. If you type in up here, you can see there's a whole lot of stuff, So there's counter, aggregate. Now this, learning about counters and summary and aggregation and things like that, that's a different thing. I'll find a video I can share with you guys that you can actually specifically, if you want to know how to use the PromQL to begin to query and get data yourself, which will actually be an interesting skill to have. I remember there was a time a recruiter called me one time specifically looking for a Prometheus and Grafana monitoring specifically specialist, and I think that role was going to be paying about £650 a day only to come in and just work on this technology. So that's to tell you, this is not joke. And for that kind of role, you obviously want to then drill into knowing how the counters work, how to query Prometheus to set rules and configure alerts and things like that. So if you hit execute here, it basically tells you which systems are up or down. All right. And it tells you, remember the alias we configured. For anyone that has an alias, it shows their instance, and you can begin to filter. So if I use the curly braces to open it up, I can filter by the things, coming from the metadata for this up. So for example, it has seen that with the up, it has alias, it has instance, it has job. So if you want to filter by, let's say, job, you can say job equals. So it's telling you can either use wildcard or say specifically if you want it to be equal to something, you can just select it. And in quotes, you can then put, and the good thing is the options are coming up for you. So you don't really have to just write anything from your head. So if you're interested in whether maybe alert manager is up or down, you can just execute that and it's going to bring back only alert manager. And it's possible for alert manager to be running on a different system. So it'll tell you the server, the location, and all that. So what we will do is we'll go into our etc folder, we'll create a rules file, and then we'll set a rule configuration. So if you go into Prometheus here and go into status here and go to rules, you can see there's no rule, nothing has been configured. Okay, so let's create our first rule. So without a rule, we can't have alert manager to alert us, because if you want it to alert us when systems are down, then you have to configure a rule, right? And that's logical. So you can see the expression here. When systems are up, that's what we want to know. So if the up is equal to 0. Now, if it's not 0, if it's like 1 or something else, it means it's down. So you can see that's basically what this is. Okay, so only tell us, when the instance is 0. Actually, let's go into it and have a quick look. If I go to targets, okay, you can see the state here is up. Okay. All right, we'll get to see that in a minute. Let's just create our rule. So in the okay, let's put this Ctrl X, Y, enter, and we're gonna need to restart Prometheus to pick that up. Start Prometheus and go into rules. Okay, let's see if rules.yml. Oh, actually, there's one more thing. So we still need to go into our etc Prometheus and Prometheus.yaml. And first of all, we need to configure alerting. So here you can see it's commented out. So we need to ensure that we remove the comments and then we tell it where alert manager is. And alert manager in this case is running on localhost. Okay, so that's the first thing. And then the next thing is rules. So you can have different rules. Okay, so in this case, we only have one rule here. So you can have multiple rules. You can organize your rules logically however you want. You may have rules for HTTP related services that you're running, for databases, for different things. So this is just a way to come into this file. Imagine if you have a long list of them, you can just know which set of rules you have configured, and you can go into and see the specific configurations. Now, this is a global setting that says, the script interval, it sets the script interval to every 15 seconds, which means at how many times do you want Prometheus to scrape those HTTP endpoints. Then the evaluation interval is how often it's going to be evaluating the rules that we set, and also here it says 15 seconds. By default, it's every 1 minute, but we can set these things however we want it. Okay, so let's save this. Oops. I actually didn't open it with sudo, that's why. So we have to do it again. Okay, so let's go in. Localhost. And what was the other thing we did? The rules. Okay, fair enough. So now let's restart Prometheus again and refresh.
So, Gary.
Yes.
So, for the YAML file, so where we have the alerts :90, like where you're telling in the YAML file. So, does it mean that if the alerts, if the alerts manager is in another, it's coming from another system, let's say another instance.
Yeah.
So what are we going to be putting there?
You put the IP address of the system.
The IP address : okay.
Yeah.
Okay.
Or if the server has DNS, if your infrastructure have proper DNS configuration, whether it's using the etc host file or proper DNS, you can put the DNS name. As long as the server can resolve that DNS, then it's fine. It can connect to it. It resolves it to an IP address, and then networking, security group, all of that is configured. And you see, this is where you get to spend a lot of time in the real world, troubleshooting connectivity issues, looking at security groups, making sure that your rules, your services, that you're configuring the ports and all that. Unlike in this case, we'll literally just open everything. Imagine we didn't open the security group to allow everything. It's not going to work initially. You have to go in, configure the security group and all that. Does that make sense?
Oh, yeah, it does. Thank you.
All right. So now that we have the rule configured, let's see. Okay. So let's refresh this for now.
I think Solomon is raising up his hand.
Oh, sorry about that. Solomon, go ahead.
It was before, not now. Sorry.
Okay. So you have your question answered, yeah?
Exactly.
Okay, good. So now everything is up because here we're saying instance up without expression equals 0. So 0 means everything is up, right? So if anyone is down, it will let us know. So let's simulate one of them to be down, and that will be alert manager. Let's say we want to. Okay, let's turn off alert manager and just stop the service. So alert manager is down. I hope it will tell us that it's down. Okay, so let's go to the target. So already it's showing that the state of alert manager is down. And Okay, actually, if we go to our rules here, it's showing a lot more. Okay, you can see here. So this is 0, this is 1. Okay, so basically these, so 1 represents up and 0 represents down. So that's what's going on here. Okay, and we've set a rule that's actually, wait a minute. Let's see. Okay, so let's go back and have a look at our rules again. Okay, so this rule is just running these to trigger an alert, the instance down, and it tells us, okay, that 1 is down, and you can see here it's showing that alert manager is down. Okay, but then we have to then configure our systems that will receive the notification when this rule evaluates. So whether it's Slack, whether it's email and all that, and that's going to be your homework because of time. There's a documentation on that, how you can configure Slack. So that's going to be in the documents that we're looking at. Yeah, here. So I'll put the documentation here for you, how to implement it with Gmail, Slack, PagerDuty, whatnot. And you can go there and, see how it works with alerting. Now, it's been 2 hours, 12 minutes so far we've been on the call, and we still have Grafana. So my question to you guys will be, should we touch on Grafana, which will probably take us another 30 minutes, or you want to push that to another day? Or there's information overload already? So let's take a poll.
Do that another day.
Okay, we have one person say push Grafana to some other day. Does everybody else agree with that?
Yes.
Okay. Okay.
Another day is better.
Another day is better.
Okay. All right. So, oops. Okay. All right, cool. So we're gonna stop here. All right. The next class, the first thing we'll do is we'll quickly wrap things up with Grafana, show the dashboard, show how it connects together and everything. And then we can move into whatever we plan to do for that day. Okay. Sounds good, everyone? So please do not forget to be very attentive on Slack and to your email. If there is any of our emails that goes to your spam, please move them to inbox so that you don't get to miss any information. So if you have any session that we're going to have maybe during the week or whatnot, you get alerted about it, and we can all come together. But other than that, I'll see you next week.
Sorry, I have a question. Sorry, before you go.
Okay. Yes.
Okay. So my question is, I want to make some comparison between this we've done and the Elasticsearch configuration. So for Elasticsearch configuration, if you want to configure the file bits on the servers, you only have to work on the servers that you want to receive logs from. That is, you only have to install file bits on the servers and add the Elasticsearch IP address, and it sends logs directly to it.
Mm-hmm.
Is that
Yes.
possible with Prometheus? Because from what I've observed so far in this class, whenever you configure the exporters on the host, on the servers, you still have to go back to where you have your Prometheus server to update the YAML file. Is there a way around this to have you do the work only on the servers without having to log in and out two places?
That's a very good question, and that's because the way Prometheus work, you can actually configure it to either pull or push. Okay, so the default configuration is Prometheus actually has to go somewhere to get its data. It's pulling the data. It's the opposite for Elastic, where it's actually pushing the data to Elasticsearch. In this case, it's a pull configuration. And that's why each of the services have their own respective HTTP endpoint. So when you configure Apache Exporter on an Apache host, it opens up an X endpoint with / metrics. And that's where Prometheus go to pull the data. But you can actually configure it so that you get to push the data to Prometheus. That's not a common configuration, but if you want that, you can actually do that as well. So it depends on how you want your Prometheus configuration to work, but the default setting is the pull method. Okay. All right. Any more questions? I think Jumoke was raising up her hand just now. Okay, cool. All right, guys. It's been a pleasure hanging out with you guys today, and I will see you next week.